This is the problem 1.1, and it has 10 parts from quantum mechanics by Richard Liboff. So the first problem 1.1 is saying that for each of the following systems specify the numbers of degrees of freedom and a set of good coordinates. So we will find the good coordinates and degrees of freedom for part A. Part A is saying that there is a bead constrained to move on a closed circular hoop. So the first problem is that let us consider this is a hoop, and there is a bead. So the problem is saying that the circular hoop is fixed in space. It is fixed in space. It is not another, like it's a kind of rubber you can consider. It is not a kind of rubber, or it is shrinking or expanding or moving in any direction. You can consider it is a fixed. It is a fixed, and the radius, it means the radius is fixed. So let the bob is moving from here up to here. Let it consider from point A to point B. This is point E, and this is point B. Let us consider. So it moves from point A to point B, so it will make an angle theta. Now keep in mind that degrees of freedom can be shortly defined as independent motion or independent coordinates. So we are describing this system in spherical coordinate. So it has angle theta. Okay, there is no phi and psi, another two angles. So there is only angle theta is changing. So you can consider this is a spherical coordinate. So shortly, I'm defining degrees of freedom as independent ways a system can move, or the number of independent parameters needed to completely specify the configuration. Or you can define the independent parameters which can define the state of a system. So degrees of freedom here is 1, because all